Now we're going to talk about the number e. The number e is a constant. It's an irrational number. It's very much like the irrational number pi. You know that pi is equal to 3.14 and a never ending. This is a non-terminating, non-repeating decimal number. That's why we call it irrational. So pi comes up a lot in geometry. So they, instead of using this number 3.14 and that whole decimal, non-terminating decimal, they just assigned it a Greek letter pi to denote that number. E is very similar. This is the expansion of the letter E. E stands for this number, just like pi stands for this number. E stands for 2.718281828, and so it never terminates, just like pi. This keeps going forever and ever, okay? And this number comes up a lot, and it's a more realistic model of how things grow exponentially. And it's just a constant, okay? So when we have e as our exponential function, for example, f of x is equal to e to the x, all we're doing is we're raising 2.7018 blah 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 to the x power. Okay, that's what it is. And if I were to graph this exponential function, notice I have 3 to the x, I have 2 to the x. Since this is 2.71 to the x, this function is right in between those two. That's what that function looks like. So don't be scared about this letter. It's just a letter to represent such a long number that we cannot write because it's so long, okay? It's 2.72 approximately. And there's the graph. And this number is, if we were going to say limits, when we start seeing limits in calculus, the limit as n approaches infinity of 1 plus 1 over n to the n power. If we plug in any n value in this function, as the n value gets bigger and bigger and bigger, this number approaches e, or it approaches 2.718, etc. Okay, so this number is like telling you this is not going to grow infinitely. It's going to reach a limit. It's going to stop growing at some point. It's going to reach a horizontal asymptote. Okay, that's what e is. It's the natural number. And here's an application of that. If the population of the United States continues to grow as it has since 1980, then the approximate population in millions of the United States in year t, where t is equal to 0, corresponds to the year 1980, will be given by this function. And notice that this function has e as the base of this exponential function. E is my base. Okay, estimate the population in the year 2015. Now this is very similar to the problem we did on population. If t equals 0 is the year 1980, then t equal to what is the year 2015? So we have to subtract 2015 from 1980. And that will give you that t will be equal to 35. So it's asking when t is 35, so I'm going to evaluate the function for t equal to 35. What will be the population? And I substitute t for 35. And if you do this in your calculator, you will get 314.3, okay, million people. Million people. And that's the answer to letter A. When will the population reach 500 million? So that's asking me, when will this value be 500 million, which is 500 million people? So it's asking 500 million is equal to this. To the t power. And what we do is we solve for t. Now, as we did with our last example, we would need to graph this function on WZ Grapher or on Wolfram Alpha. And we would look at our y value and find the y value that is equal to 500 million. And then we go across and see what that y value corresponds to on my x-axis, just like we did with the other one. And that's the way you would do it and find out what year would I have 500,000. And if you do that, you would find that by the year 2065, that's when you'll have 500 million people. Okay? And remember, this example is talking about if the population continues to grow as it has since 1980. Okay, so this is an estimate. This is not real. This is an estimate. Okay, so E, we're going to use exactly the same as you did a number. In your calculator, some calculators will have the letter E on them. It'll have this key. It looks like this, e to the x. So you would hit that letter, you would hit that button on your calculator, and automatically on your display you will get this. On your display you will have E and then this and parentheses, which means to input your exponent. Okay, so on your calculator you would hit this key, e to the x, and this appears in your display, and you input your exponent, which is this multiplication, and then you hit equal and you get an answer, and that answer you multiply by 227. It's basically the same when you have a number here, except that now we have a specific irrational number. Okay, I hope you understood this problem, and we will do another one on radioactive decay. Okay, I'll see you in the next video.